Hi, it's Sam from MinIO. Welcome to the final video in our series on modern data lakes. To wrap things up, we're going to tie our modern data lake architecture back to some of the key features that MinIO provides. We're also going to briefly touch on some of the use cases that MinIO can support, and then finally review why high-performance storage is so critical in your modern data lake architecture. If we take a look at this slide here, we'll see many of the key features that MinIO offers today. We're not going to have time to go through all of them here, so instead, let's explore a few in particular that might be useful to be aware of in the context of a modern data lake. Firstly, we have S3 API compatibility. By making sure that our API is completely S3 compliant, it means that MinIO can easily support a huge ecosystem of tools for data processing and machine learning. This allows for optionality when it comes to picking your compute engine, catalog, table, and file formats. The next feature I want to mention is encryption. Privacy and data security are obviously table stakes for your modern data lake, and here again, MinIO is going to support encryption both in transit and at rest for the objects that are stored in your infrastructure. We also offer Lambda compute functions, which can be a great way to tie your data lake into a larger ecosystem of microservices and APIs. In practice, you can do this by setting up triggers that are tied to business events, which move data in and out of your data lake accordingly. The last item I want to call out here is erasure code and bit rot protection. At MinIO, we use a number of scalable algorithms to make sure that you never need to worry about data loss or corruption, even as you scale your data lake to petabytes of data and millions of objects. If we look at this diagram here, we'll see how the landscape has evolved, from enterprise data warehouses in the 1980s all the way up to the modern data lake in the mid-2020s. Because MinIO is so interoperable, it means that regardless of whether you want to build a traditional on-prem data warehouse or a modern open-source data lake, MinIO should have no problem fitting right into your architecture. If we look at some of the common tools in the modern data lake, we can see that performance at scale is extremely important. Nearly all modern compute engines, for instance, use massively parallel processing, and so are capable of utilizing enormous throughput at the storage layer. Likewise, all the modern open table formats, like Iceberg, Hudi, and Delta Lake, for instance, make use of distributed partitioning to allow queries and ETLs to run in parallel. MinIO's multi-node architecture means that you can scale performance linearly along with the number of storage nodes you use in order to make sure that your storage does not become a bottleneck for the queries and data transformation jobs running on your data lake. If we zoom out a little, we can see that modern data lakes are really the center of gravity for companies working with lots of complex data. Data practitioners get access to some really powerful tools that make them more productive for analytics and AI projects. Ops folks get performance and scaling benefits that come from picking the best tool for the job, and companies get the flexibility, security, and cost benefits that come from running an open stack they can deploy anywhere. And that's really it for this series. I hope you enjoyed these sessions as much as I did putting them together, and I hope you learned a thing or two that you might find useful in thinking about your modern data lake architecture.